The safety procedure of this experiment is we must inspect the equipment, which is the multimeter. We must check the multimeter for any physical damage, including cracks or loose parts. Also, we must inspect for damage. We should ensure the test leads are intact with no cuts or exposed wire. Not only that, we have to confirm that the probes are securely attached to the multimeter and the correct input terminals. Last but not least, we must ensure it is set to the correct continuity mode. The display should show 0 ohm. For the oscilloscope, we must verify that the power cord and the connection are intact, and we should connect the probe to the calibration signal terminal, which is often marked on the oscilloscope. Hi, my name is Discipline. Today I am going to be practical book 2, which is about diode and rectifier circuits. A diode is a semiconductor device that allows current to flow in only one direction. Because of this property, diodes are commonly used in rectifier circuits to convert AC voltage into DC voltage. The objective of this experiment is to study the operation of half-wave rectifier and observe the input and output waveform using an oscilloscope. The components used in these experiments are one diode, one load resistor, function generator, oscilloscope to observe waveform, and connecting wire in breadboard. To conduct this experiment, what we should do is, using the oscilloscope channel 1, we have to measure the input voltage waveform at terminal A and B. But before that, we need to make sure our input setting in procedure B is 4 VPP by using 500 Hz as VIN for the circuit in figure 2.4. And then using the oscilloscope channel 2, we measure the output voltage waveform, which is Vout, at terminal X and Y. We must make sure we set the AC ground switch of the oscilloscope to the DC position. As we can see on the oscilloscope, channel 1 shows the input AC sine waveform generated by the function generator. This represents the original alternating signal before any rectification. On the other end, the channel 2 displays the output waveform measured across the resistor after the diode. Here, we can clearly see the effect after the diode. Instead of a full sinusoidal signal, the only positive half cycle are allowed to pass through, while the negative half cycle are blocked. This produces a pulsating DC output, which is the characteristic behavior of a half-wave rectifier. By comparing channel 1 and channel 2, we can directly observe how the diode modifies the waveform. The input remains a pure AC sine wave, while the output across the resistor becomes clipped and rectified, demonstrating the diode's role in converting AC into DC. This visual evidence reinforces the theoretical concept that diodes conduct in forward bias and block current in reverse bias, making them essential components in rectifier circuits. In conclusion, this practical work has shown how a simple diode can perform multiple essential functions in electronics. As a switch, it clearly demonstrates the on-off states through forward and reverse bias. As a rectifier, it transforms alternating current into direct current, with the half-wave rectifier producing a pulsating DC and the full-wave bridge rectifier giving a smoother output. Through the Clipper circuit, we also saw how diodes can shape and limit signals, protecting circuits and controlling voltage levels. Overall, this experiment proved that diodes are not just basic components, but versatile devices that play a critical role in modern electronics. From switching and rectification to waveform shaping, the diode remains a cornerstone of design and power conversion. If the polarity of the probe that touches the base is positive, then the transistor is a NPN type transistor, while with the reverse polarity, it indicates a PNP type transistor.